This is Mr. Ward, and this is a Do Now video key for Geometry Do Now 25.3. And here are some properties of kites. This is a kite. A kite has two distinct pairs of consecutive sides that are congruent. And that what we're saying is these two consecutive sides, one after another, are congruent, and these two consecutive sides are congruent. So you'll have a pair of consecutive sides that are congruent and another pair, a distinct pair of sides that are congruent. Another thing about kites, which won't really apply in this proof, is that one of the diagonals is a perpendicular bisector of the other diagonal. And that is because if these two sides are congruent and these two sides are congruent, then x is equidistant to the endpoints of TS, and V is also equidistant to the endpoints of TS. And if you've gotten to the sections of chapter 5 that talk about perpendicular bisectors, if a point is equidistant to the endpoints of a segment, it is on the perpendicular bisector. So V and X are on the perpendicular bisector for TS because they're equidistant to the endpoints of TS, and therefore Vx is a perpendicular bisector for TS. So that's an implication of this definition, and it is also true. However, we're going to need the definition, the first piece. We need to prove that two pairs of distinct pairs of sides of this shape here, this figure here, are congruent. So we have been told that GH and GK are congruent. So we've been told this, flump and flump, we've been told that. We've also been told that HM and KM are congruent. So that's nice. So which pair of segments would we need to prove are congruent beyond the givens? Well, in order to prove that this is a kite that has two distinct pairs of congruent sides, the segments we need to prove are these two. We need this pair of consecutive sides to be congruent. Okay, that's what we need. We do not yet know that, so that's why I put question marks. We do know these two are congruent. We do know these two are congruent. And so, and by the way, that technically makes this a non-convex kite, but that's not a standard thing we'll be dealing with for here. But or just, HMKG would be a non-standard one. But we're looking for HMKJ. The two segments are HJ and KJ. Okay, those are the ones we want. Now, which triangles? We can't really prove anything about these triangles yet to prove that HJ and KJ are congruent, but we do have the ability to prove a couple of triangles are congruent because we know that this is congruent with this, and we know that this is congruent with this. Then, and because of reflexive property, we can say this is itself. We can prove that triangles, we can prove that triangle GHM is congruent to triangle GKM by side, side, side. Okay, and that's how we can prove it. Now, once we've proven that, this is very useful because this is once we've proven that these two triangles, this sort of paper airplane thing, are congruent, we can add some additional information. So I'm just going to go ahead and put in the relevant information. So we've proven that these triangles are congruent by using some of this information. So flump, flump, and flump. So we know that. What that also allows us to do is come up with a couple of different ways to prove that HJ and KJ are congruent. And here's how we can do it. So because these triangles are congruent, by Kappa-Kadika, these angles are congruent. And in addition, these angles are congruent. And if these, so we have two paths to victory. Now, because this side and this angle are congruent with this side and this angle, one path to victory is to actually extend this thing all the way out to J. And then by reflexive, so path 1, prove that triangle GHJ is congruent to triangle GKJ by side angle side after using the reflexive property to prove that, oh, it looks like this is a short answer option, to prove that GJ is congruent to GJ. Okay, now option 2, pathway 2, we'll fix this characteristic of this question in a minute, but path 2 would be to take the fact that this angle and this angle are congruent, and then we can say that therefore, because this angle and this angle are supplementary to congruent angles, we could say that they're congruent to each other. And then we could further on say that this side is congruent to itself. So our other path is to say we can prove that triangle HMJ is congruent to triangle KMJ by side angle side by proving, this is a couple of steps. We would have to prove that angles HMJ is congruent to angle, so angle HMJ is congruent to angle KMJ because they are sup to congruent angles, and MJ is congruent to MJ by reflexive, and that would allow us to prove those triangles are congruent. Okay, once we've proven these triangles are congruent, okay, once we've proven those triangles are congruent, okay, that we have either of those paths, we can say that HJ is congruent to KJ by kappa Kataka, and therefore HMKJ is a kite by definition of a kite. Two sets of consecutive and distinct pairs of congruent sides. And there you go. I hope that helps.